I asked AI, how much light in lux hits our eye from Mars? Using Mars' apparent magnitude, given to us by mainstream, it calculated the maximum and minimum lux values. Also noting that this is well below the threshold for color vision. And a clear contradiction, that you can still see its faint color with the naked eye. To see color, it would need to be over 300 and 4,000 times brighter. I pointed out that this is also below being visible. After checking the numbers, it concluded I was absolutely right. This created a paradox. Mars should not be visible according to the numbers, but we can see it. The AI considered that some of its calculations could be wrong, even considering how we see light differs for point and extended source light. To make sense of the calculations, it asked for more input. I suggested that Mars is a lot closer and smaller than we're told. The AI commented that this was a very interesting and profound observation, also stating that for Mars to provide enough light, it must be brighter or closer. I asked it to recalculate the values. It came up with the same results. I asked again, this time for 4 planets, using their radius and distance from the Sun and Earth. Again, the levels are the same. The AI proposes that either a fundamental error with the conversion formula for planetary bodies, or the distances and sizes are wrong. I asked for the amount of lux from each planet. As you can see, using these calculations, none of the planets should be visible. I suggested using this formula. It calculates the surface area of a sphere. It produced data for Mars and the formula to find the light hitting Earth using the inverse square law. Then querying using official distances and sizes, or others. It again queried the numbers. I told it to use the official numbers. It asked me to double check. All the values were far below what's needed. Something was wrong. The distances and sizes in the official figures do not add up. You may have noticed 100,000 lux at 1 astronomical unit is incorrect. Even with the correction, the values are far below the threshold to see them. I then asked to include Jupiter. The AI has tried several ways to calculate the lux values arriving on Earth from each planet. The values are far below the threshold needed to see any of them. We could only see them if they are smaller and closer. Let's see how the AI deals with the 4 brightest stars in the night sky. Using the inverse square law, Sirius would be impossible to see at that distance. As I had previously calculated, none of the stars should be visible. Using the no physics of light, the inverse square law, at the distances mainstream tells us, not one of the 4 brightest stars should be visible. I asked whether there was any other way it could calculate this, to make the light or lux level brighter. It came up with converting apparent magnitude to lux. As you can see, even this failed to make the light level sufficient enough to be able to see directly, at their stated distances, the 4 brightest stars in the night sky. They must be closer and smaller.